Hello everyone, Sawadee Krap and Namaskar. Welcome you all to the Environment Technology News Hour. This is a weekly online program on environment technology, and it is a Technobiz program on every Tuesday. I welcome you all for this the episode of the Environment Technology News Hour. As you know, this program is managed by Technobiz, and you can always check more information about Technobiz at technobiz.org. Just brief you about Technobiz. Technobiz established in 2005 and is recognized as International Resource Center for Industries and Technologies. And basically, there are two types of services. One is professional education, other one is business services. Let me brief you about various services that we offer. These services are pretty much global. We organize trade exhibitions. We do have training programs and conferences, webinars, where we have business networks and also publications, and we do a lot of integrated marketing and technical consulting. All these activities are involved with engaging all the stakeholders, building the skills and business, and also integrating the marketing and the branding of the companies and the technologies. So these are the services we offer. When it comes to the business focus, we have two types of segments. One is a polymer and this other one is non-polymer. When it comes to the polymers, we cover on rubber, plastics, polyurethane, adhesives, and coatings. And when it comes to the non-polymer, chemical engineering, energy environment, water and membranes, filtration, separation, and also the advanced materials and the technology. Again, all the services for these segments, it's all involved with education, professional education, and business services. I'd like to introduce to you, as you know, we offer organized exhibitions. So we have an exhibition, Membranes and Filtration Trade Expo, during 29th to 31st March in Bangkok. And at the same period, we also have an exhibition called the Recycling and Recovery Trade Expo, which is also at the same time, same venue with the membrane filtration. I welcome you all to participate in this event. We have developed a number of training programs focusing on membranes and filtration. We developed 32 modules focused on EFMF filtration, desalination, reverse osmosis, ceramic membranes, MBR. So these are available on schedule as well as on demand. You can check more details about these programs at knowhow-webinars.com. These are some of the books we have published. These are available from our Technobiz store. You can go to the store.technobiz.org. We have a book on the EFMF membrane water treatment, desalination. Please check the details on how to purchase them at the Technobiz store. Okay, let's welcome you all for this episode, Environment Technology News Hour, episode number 14. Today, in this episode, our focus is on the ceramic membranes from India, technology and applications. And this presentation is given by Dr. Sandeep Sarkar, who is the Managing Director of Keraship ceramic membranes based in India. So let's welcome Dr. Sandeep Sarkar to make a presentation on the ceramic membranes from India, technologies and applications.
Namaskar everybody. Thank you very much Technobiz Communication Limited for giving us this opportunity to showcase our technology. Today my topic is Keraship ceramic membrane from India and its application and technology. From Need Innovation, Kolkata. So we manufactured ceramic membrane for water and wastewater application, along with process applications, starting from food to pharmaceuticals, etc. So the discussion today will be will having the content of the following contents: importance of separation science and technology, new technology in membrane and membrane science, classification of membrane with respect to membrane material of construction. Then we'll discuss about the membrane market and the advantages of Keraship ceramic membrane. We will also discuss about the gaps in the market and where and how Keraship ceramic membrane fill up the current existed gap. We will also discuss about some of our product portfolio with respect to application in liquid, followed by some case studies of Keraship ceramic membrane in India in the past 5 years we have undertaken. So, to begin with, we will discuss the importance of separation science and technology. Now, we know the cell is the fundamental building block of life. The three most important ingredients required for cell is organic compound, that is the amino acid, and a media, that is water, in which the activity of life will happen, and then a separating layer through which the cell interacts with the world, that is a form or a membrane. It gives the form to the cell. So we can see the importance of membrane goes way back to the origin of life. So what is a membrane? In a very layman language, we can describe membrane as a physical separation layer to separate the wanted from the unwanted. Selective permeation, through selective permeation. That is membrane. Now we know separation science is considered as one of the most important, if not the important, unit operation for modern day mankind. We find its application in biological activities, as cell we just described, to all kind of industrial activities. Any activities where there is a requirement of liquid, we need a membrane. Thus, membrane is considered as one of the most important tool in separation science. The new technologies in membrane and its classification with respect to membrane material. The first generation membrane is considered as liquid membrane, or to be precise, the technologies through that membrane is settling tank, clarifier, etc. The second generation membrane is considered as polymer membrane, which is bit more rigid compared to liquid membrane. Then comes ceramic membrane. It is considered as the third generation membrane technology, simply because of its technological superiority. But the problem with ceramic membrane is it is very expensive. The reason is it is a thumb rule. It is considered as a thumb rule for any ceramic product. 80% is the processing cost and only 20% is the raw material cost. Now, why 80% is the processing cost? Because the formation of ceramic required high temperature, whereas For polymer, it can be developed and manufactured at a lower temperature, like room temperature. That's where the price lies. That is the reason, though it is ceramic membrane, it is considered as the fourth generation membrane technology. It has not been widely applied simply because of its high cost. So when we started this company, our major and only, I would not say major, it is the only objective is to provide a ceramic membrane at a very economical cost, economically. So our USP is we have developed this ceramic membrane technology at a fraction of currently available ceramic membrane. The cost is so advantageous that we compare it with current dispensation polymer membrane. Now, if we see the global membrane market, we see that out of this 13 billion USD membrane market size, approximately give and take, 95% of the market share is by polymer membrane. Only 7 to 5% is ceramic membrane. In India, the scenario is much more worst. It is only polymer membrane. The primary reason is, as I told, the cost, high price, and availability of economical ceramic membrane. Now, this is the advantage, this is the gap which I was talking about, and we intend to reduce this gap. We intend to increase the membrane market share of ceramic membrane from 5% to more. That is our target. Now, how do we do that? So, before we get into that, I would like to empathize, emphasis. I would like to emphasize about the advantages of ceramic membrane, Keraship ceramic membrane that is being bring to the table. The first and foremost is, of course, the longer life. It has a life expectancy of 15 to 20 years when you compare with polymer membrane of 1 year to 5 year. It has higher flux, that is output in terms of liter per meter square per hour. It is up to 6 times the polymer membrane due to its intrinsic property, which I will cover in the later half of the presentation. Then we have application versatility of Keraship ceramic membrane because of its configuration. The above three boils down to the affordability part. It was found that with Keraship ceramic membrane, the cost to customer comes down to one third compared to the current dispensation of polymer membrane market. The longer life. We know that ceramic is the most robust material found in the earth. It is chemically, mechanically, and thermally much more stable than polymer material. That is the reason it can be backwash at higher pressure for cleaning during backwash cleaning. It can be cleaned with corrosive chemicals compared to polymer membrane. It can be also steam sterilized, which is necessary in some of the applications like pharmaceuticals, dairies. It can withstand high pressure during cleaning, and it can be cleaned with corrosive chemicals also. Thus, the life of polymer membrane is only 5 years, when with Keraship ceramic membrane it is almost 10 20 years. Because of its intrinsic property of ceramic material, it has higher flux. as you can see from the graph. Aluminum oxide has the best hydrophilicity compared to any kind of polymer membrane. The good the wetting property, better the flux. Now, application versatility of Keraship configuration. Now, if you see a polymer membrane, a typical polymer membrane, hollow fiber, each fiber has an inner diameter of less than 1 millimeter. Because of this, any application fluid with higher TSS, more than 0.5 to 1%, it tends to clog. And because of the clogness, there increase the pressure, which eventually lead to fiber rupture. But we can see that with Keraship, the channel diameter is 3.5 millimeter by 3.5 millimeter. What it does is it increases the flow velocity and thereby help to handle high TSS of up to 1% solid loading. Apart from that, as I mentioned, it is chemically, thermally the most stable membrane material available in the market. That gives us a versatility of application. We don't have to worry about the pre-filter as much as we have to do in case of polymer hollow fiber. Now, if we see the configuration of Keraship compared to conventional ceramic membrane, 19 channel ceramic membrane, you see that the channels are square in shape. Because of this unique shape, we have higher surface area to volume ratio. That is, a same membrane, same size of ceramic membrane has 40% less surface area compared to Keraship ceramic membrane. The difficulty of maintaining that kind of square shaped channel is it tends to develop cracks during the operation. But you can see our Keraship channel shapes are not exactly square. It is rounded at the edge. Thus we can have a higher surface area compared to conventional ceramic membrane. This is a proprietary design. This is the structural morphology of Keraship ceramic membrane. The membrane materials are primarily zirconia, titanium, mullite, silica, and aluminum trioxide. The base is 1 micron. Over that, we develop 0.3 micron, and over that, we develop 0.03 micron. This different pore size is selected based on the application, of course. Now, with those pore size distributions, Keraship ceramic membranes filtration spectrum is as this. This is we can remove suspended solid, microorganism, bacteria, algae, starting from ultrafiltration to particulate filtration. Now, when you see the affordability part of Keraship in terms of capital expenditure, we see that with conventional ceramic membrane, it is 15,000 INR per 100 liters of purification membrane. 100 liters of water purifying membrane. For polymer it is 3,000 rupees, 3,600 rupees, and for kerosene it is 6,400 rupees. We can see that it is less than half the conventional ceramic membrane, but with polymer it is marginally higher in terms of, when you see in terms of capital investment. But when you see in terms of cost to customer or cost to ownership over the period of 10 years, only 10 years, we see that it is coming down to less than one third of conventional ceramic membrane and almost half of polymer membrane. It is further comes down to one third when you consider 15 to 20 years of operation. At Need Innovation, we developed tubular ceramic membrane to flat sheet ceramic membrane. This is a flat sheet ceramic membrane with microfiltration membrane layer over it. Likewise, for tubular membrane, we know that flat sheet ceramic membrane, there are certain particular applications where you need flat sheet configuration like membrane bioreactor or with high TSS. So for that we have developed this flat sheet ceramic membrane along with tubular membrane. We have unique UPVC ceramic membrane module. It is similar to the polymer hollow fiber UPVC module fitting. Thus, it is very easy to install. No need to have prior training because the fittings and the size is exactly the same as that of polymer hollow fiber membrane. It can be retrofitted in existing membrane plant. It is patented and it is one of the true Make in India initiative. It has pore size of 0.3 micron which can remove TSS and particulate filters. Because of its ceramic nature, it has the highest flux, 3 to 6 times the polymer membrane. Now we will discuss some case studies which we have undertaken during our last 5 years, including this pandemic. This is a particular very interesting case study. There is a river called Tungabhadra River in Karnataka, in southern part of India, where there is a dam. In spite of there is a huge source of water, there was a drinking water scarcity nearby village, in the nearby villages. Now, government of Karnataka, along with our OEM, approached us with for the technology, and we have implemented this technology of river water purification since 2019. Since then, we are successfully conducting this application. The technology we have implemented is primary settling followed by Keraship ultrafilter membrane and directly to the filter water. We can see when you compare the conventional process with Keraship process, we can remove intermediate lot of intermediate processes like sand filter, flocculation, chlorination. This reduces the overall land area requirement. It is estimated that approximately 70% of the land can be reclaimed when we consider existing conventional raw water purification system. Thus, it has reduced the cost of ownership to less than 50% of the current dispensation. Another case study, brine filtration or pre-filter, RO pre-filter, which we have undertaken in one chloroalkali industry. We have implemented membrane pore size of 300 nanometer and got a TSS less than 0.5 milligram per liter. This is another case study for effluent treatment plant. This is particularly with car wash water in the automobile sectors. You see, with car wash water, there is high solid loading. In this current particular study, we have found a maximum solid loading of 2000 mg per liter, oil and grease of 10,000 mg per liter, BOD, COD is very high. And we have seen that we could reduce that TSS, oil and grease, BOD and COD to less than standard discharge, standard effluent discharge characteristics implemented by the state. There is another study, sugar cane filtration. These are the parameters which we have successfully maintained. This is particularly a client in Dulagar sugar factory, Meerut, near New Delhi. Details of this can be easily available. Please contact us. This is the Keraship state-of-the-art production facility of industrial scale ceramic membrane, which is first time in this part of the world. We have LPG fired furnace of 1550 degree centigrade maximum temperature, where we are manufacturing this ceramic membrane currently in Kolkata. The applications which we have undertaken with Keraship ceramic membrane for liquid are industrial effluent, industrial processes, sugar, dairy, food processing, distillery, pharmaceuticals, chloroalkali industry. We have applications as desalination as a pre-filter for desalination. Then we have commercial potable water, domestic potable water, etc. Thank you very much. For further details with any kind of applications, I welcome you to contact us or Technobiz Commercial Communication Limited, where we can discuss your particular application and then provide a solution. Thank you. Thank you very much.
Thank you, Sandeep, for the good presentation on the ceramic membranes. I think that is a trend now, replacing some of the polymeric membranes, particularly in the EF market. So let's have short discussion on what is going on this ceramic in membrane industry. At the same time, also some of the solutions that you're offering. Before we go and talk about it, hey, what is Keraship means? what is the name? What is the story behind that Keraship? Let's
Yeah,
understand about Keraship. Yeah.
yeah. Thank you again. So, Keraship, the word Keraship came from two words. One is Keramat. Keramat basically, it came from Sanskrit word Keramat. Keramat literally means to burn, or you can say like a mud,
Yeah.
ceramic. So from that we took Kera, and sieve basically is a filter. So it is
That's
a ceramic filter. That's how the name came.
super. So, your trade name has some valid meaning there. Yeah, Keraship. Is it how you pronounce it? Keraship, Keraship. Is it?
Keraship.
Okay, Keraship. Okay, let's want to make sure that people understand your trade name well. Keraship. Ceramic membranes from India. Are there any more in suppliers from India? Ceramic membranes. You are the one of the
Yes,
guy.
one other company, they're a national company. They're trying to develop it with my parent organization. Yes, they are one
Okay.
another.
So there are basically two ceramic membrane manufacturers from India. Yeah, okay. You are one of
Yeah,
the person. Okay, that's good to know, because you hear many international suppliers of ceramic membranes. Okay, so it's good to know that uh, manufacturers in India too. Okay, that's good. Um, See, I understand that you in the beginning of a presentation you were a PhD and you did PhD in ceramic membranes, and also that you work for the CSIR, Council of Scientific and Industry Research. There also you work on the ceramic membranes for, I think you worked for 11 years. Okay, can you talk about your journey there? Okay, what
yes,
kind of work you did? What was your research about? It looks like the ceramic membranes in your blood now, more than I don't know how many years now, 15, 6, 20 years close to, yeah,
yeah. It's almost 20 years, 17 years to be
17 years.
precise.
Okay, yeah. Yeah, can you talk about
So
your experience in the
yeah,
your CSR and all
yeah,
the PhD? Yeah, yeah.
yes. So basically, I'm a trained chemical engineer from Jadavpur University, and I did my PhD on ceramic membrane. Uh, Fundamentally, it is a subject of material science with special reference to ceramic membrane from uh, Jadavpur University, Kolkata, and Institut Européen des Membranes, Montpellier. It is a city in southern France. It is an institute of membrane technology from there. And I was working as a senior scientist in CSIR, one of the CSIR lab. CSIR is a Council of Scientific Industrial Research in Kolkata, and my subject was, of course, ceramic membrane there also. I've been working uh, with ceramic membrane, as I told, for the last almost 17 years now. And during that period, I had some couple of technology developed. I was one of some of them. I was the inventor, and I hold some patents with my parent organization, with CSIF, before I quit my job and started this company in 2017. Yes, pretty much that's some of my.
So you are more of a startup guy, is it? You can say so.
You can say so. I mean, just
Yeah.
started. I don't know if
I
startup
mean,
means.
at that time, now is a buzzword. I think you're talking about 2017, right? You started 2017. You you left as a researcher and you became an entrepreneur. That's a big jump, right? How was your journey? Since you start,
So
what kind of
yeah,
experience you have? Yeah.
yeah. So before I go to that, I just say how I came down. I mean, why we started. I mean, I was working with this technology, ceramic membrane, and as you know, my PhD is also ceramic membrane. I have a couple of patents also in ceramic membrane, and I was discussing with a lot of industry guys at the time. But there is a issue with Indian academia and the industry. They're like a train kapatri, rail line. They don't coincide with each other. So that was something that was a very pain point for us and for me particularly. And during that time, my director, Professor Indranil Manna, and my boss, immediate boss, Mr. Dr. Siddharth Bandyopadhyay, they've also supported me to commercialize this technology with CSI. I tried, but I failed. The reason was there was a trust deficit uh, by the industry guy. Anything developed in India might not be that good at that point of time. There was a belief it has to be from the outside. So that pinched me, and I was struggling. I was struggling to establish technology, and we had a couple of discussion also. One of the discussion is that our another company in India, they're also doing it in India, but they were not. I mean, it was not wholeheartedly approached. So I found that I saw that if it has to be put into the market, the person who has developed it or worked throughout his life, he has to take that chance. And hindsightly, when I see, it was not it was not a very bold decision. People may think that uh, leaving a very lucrative job and started this thing, because I was discussing with a lot of industry, and I found that in the demand part there was a huge uh, gap, and there is ceramic membrane. Internationally it was found, but the cost is very high, and the cost which we are making it, it is a fraction of the international ceramic membrane. And we found that if we can provide this solution to the market at a very fractional cost, then there is no way of failure, which is true. We found, which is true. Sometimes I feel that um, the decision was very at a moment, but at that time I didn't feel that it was a risk. I was feeling that I was just promoting it. I was just promoted to next level. Yes, I got a lot of support from my colleagues. Some of my colleagues are also right now associated with me in my company. That's also another support. And then we started it. Government also came with initial support funding. Still, we are looking for that expansion mode. But we are very satisfied that we could bring down this technology in India, and we have applied across the spectrum this technology across the filtration spectrum in liquid, in liquid applications.
So it's a good to know that I think it's you're involved in the development of technology. You had patents, and you found it very difficult to convince the industry to take a part commercializing it. Okay, let's do it. I know what it is all about, so let's do it. And you started it, and with a friend, with your colleagues together. And I think it's very nice that your colleagues and your ex-bosses be supportive and take care. Yes, you rightly mentioned it's not a risk. You actually are promoted. Okay, whenever you get being promoted, you get more responsibilities. Now you are in a more responsibility to develop a business. Okay, that's very nice. That is very inspiring for, I think, other young people who are thinking, they have an ideas. They can put an effort. You're running the business since 2017, right? Yeah. So
That's correct.
yeah, 2017, it's almost like 7 years. Okay, you have a hard years of probably 2 years COVID in between.
Yes.
Okay.
Yes.
So yeah, I think you rightly mentioned, is very correct, that huge demand is there in the ceramic membranes, and it can really give a lot of applications in, in the areas of the polymeric membranes, particularly the EF membrane. And you are also, that is a good thing, that it is more cost effective, okay, when you compare with the other leading manufacturers in other parts of the world. So well done, man. That's very nice. Okay, congratulations, and I want you to keep it going to the next level. I'm sure that the governments will, give more support, and because the demand is there. Okay, you mentioned that you have done in Tungabhadra River, the project, the dam, river dam. Can you talk about the, any operational problems? What kind of operational problems you experienced while you're commissioning the plant or handling the ceramic membranes? I'm sure that never be a cakewalk. Okay, I'm sure that you've been some practical. Are you able to share some insights about it and your success of the Tungabhadra River Dam water purification, please?
So yes, it was certainly not a cakewalk because of the following reasons. First is that the technology is new and implementation is also has to be new. So finding the right person to implement that, it was first challenge. And the second challenge is acceptance. Acceptance not to the end user, but to the implementer, like government agencies and all. Because at that time, very few people have heard about. I mean, they have heard about ceramic membrane, but it can be used in such common applications. It was not very much, popular at the time. And then to add to that, it is very expensive. So to break that, it is very expensive. It's not expensive. It is actually economical compared when you compare its life and its application parameters. That is one first challenge to make them understand that this is really doable. That actually took us almost 3 months to convince the guy in the government to give us the opportunity. And after that, yes, in the real implementation part, it was not a big challenge. The reason is it is like a ceramic membrane. What we are providing is not only membrane. We are providing membrane with the housing. So it is like a block. We just developed it in factory, and then we are assembling in the actual site. So that was not a problem. Then yes, some problem was there to how to operate operation wise, as I told, implementation wise. But once the people, because it is technologically it is superior in application wise also, it does not demand lot of care. And when we started this plant, it was a semi-automatic. Now it is almost it is almost automatic. We're also planning to have a IoT link service to that plant, so that we can operate it from our factory or from our partners office. That was pretty much what we faced.
Yeah. See, when you're operating ceramic membrane plant, or what kind of operational parameters that you need to monitor in terms of the feeding, or what do you have some kind of guidelines? Okay, these are the feed water requirements, or during the operation, what you need to monitor.
So for ceramic membrane compared to polymer membrane, the guidelines are not very stringent. The guidelines are not very stringent with respect to membrane or the life of membrane. It may be important with respect to the operation. So what happened? Since it is ceramic, you can put anything. I mean, you can again regenerate it almost 99%. But the regeneration part will be difficult if you don't take care of the primary filter unit. I mean, when you put lot of high TSS, it is tends to clog, foul. That will increase the frequency of backwash. So the primary thing is to have a very minimum, minimum fluctuation of TSS. Again, it's not always, it cannot be very much maintained because season-wise, right now it is a rainy season are coming, the turbidity increases, and then the primary settling operations many times does not provide optimum results. So at that time, there is a surge of TSS, the membrane get fouled. Yes, it get fouled. But the advantage of Keraship is compared to polymer. In polymer, if it get fouled, it is almost irreversible. More than 50% times it is irreversible. You have to throw the membrane. But with ceramic, you can have very high corrosive, very strong physical pressure. You can remove that without breaking the membrane, and you can use very high corrosive chemicals to wash. So those are the things which you have to.
Okay, I had to add the point here.
Not
Even the polymeric membranes, um, of course, there is always cleaning process is there, and it lasts for a while until you dispose them off. Okay, and, cleaning process, membranes get fouled even whether it is you have a variations in the feed water quality. Okay, but still, membranes get fouled. That is a process of the membrane filtration, and cleaning is a part of the process. Okay, okay, and so there is a certain periods, when to backwash, when to clean the membranes, procedures, right? Can you talk about how to clean? What is the cleaning procedure of the ceramic membranes? Is it
so
variation with the application? River water one type process. Let's say sugar cane filtration is a different. So because the what you call the impurities are different, right? So can you explain about how to clean the ceramic membranes during the process, or if you want to dismantle, regenerate them, what to do, how to do about it? Yeah.
So primarily we have to. There is two way of cleaning the membrane. That is backwash. That is continuously every 30 minutes to 1 hour, depending on the TSS. You have a backwash. Backwash sequences are there for every backwash. You have particular time of backwash and particular pressure, along with some aeration also, along with some air also will be, air purging also will be done to create a turbulent, to break the foulant. That is the cleaning process in the during the process. And then depending on the um, nature of impurities, you have chemical cleaning. Chemical cleaning depending on very weak acid, the same forward washing, that will be varying from 3 days to 1 week, depending on the nature and quality and quantity of impurities. And then if it is there are some applications like protein hydrolyzed protein filtration and all. There every month or 45 days, with the chemical cleaning has to be in a different when you do chemical cleaning, the chemical has to be, after cleaning, the membrane has to be thoroughly rinsed. Otherwise that chemical may hinder the process. The stress of chemical may hinder the process. that is very important. But there are certain applications where the membrane has to be very much, it has to be very much rinsed, and it has to be with different chemical. So in that case, you have to remove it, of course. They are cleaning it with very corrosive chemical, and then rinsing, and then again checking if there is trace amount of acids are there. After that, again they are reinstalling it. But there are
So,
these are not have to remove the membrane. Membrane will be inside that system only. Inside the system, in situ, you can clean it chemically and mechanically.
so you provide a guidelines for the people, the users, that how to clean it, when to clean it, what kind of chemicals to be utilized, use it. What is the procedures. Is it right? Yeah, you provide them. Okay. And in your experience, is ceramic membrane has a chance to get damaged physical damage?
Yeah. Normally, if you see the structure of ceramic, normally ceramic has a very high compressive strength capability, but low flexural strength. So if there is a impact, I mean, if you fail it, it will break. Certainly, it will break. But taking care of those things, it is literally indestructible. you know.
Okay. And we do have sometime we had to shut down the plants for maintenance purpose. Is there any procedure before we shut down the plant, how to take care of the ceramic membrane plant, so the section? Just like in RO, right?
So
if you're going to stop for a month or a week, okay, and there is a way to handle it, otherwise that you get in big trouble afterward. After 1 week, you totally stopping the plant and utilizing after 1 week, and then it's going to be huge cost to deal with it, right? Can you talk about suppose a customer has to go for maintenance on the plant, what are the process, whether it is in the factory or whether it is a dam or wherever it is, okay? What are the guidelines to be followed for the when you want to stop the plant for a few days or months or whatever it is? Yeah.
So if you see module wise, there are two parts of a system, of this filtration system. One is the pre-filter, and then followed by ceramic membrane filter. It is the same for polymer membrane also. There is a pre-filter and then there is a ceramic filter. Now, when we will discuss, when we are saying that specification of plant, operation and maintenance, I will discuss about the ceramic membrane part. Apart from that, it is same for every application. But ceramic membrane, as I told you, it does not require any kind of skill. I mean, too much skill is not required, because of the technological advantages. Whatever skill is required, it already been done in the factory itself. There you require the high skill ceramic. Once it's formed, it is robust.
Yeah.
So there is no primary criteria as such. But of course, apart from that, engineering criteria will be there. Removing and all that will be there. But apart from that, we don't find any kind of special attention you have to give for maintenance and operation. That's the reason it is considered as the fourth generation. It is technologically so much superior, it can take care of itself.
So it's easy to use, easy to operate, yeah, and cost effective. Yeah.
So, yeah, because it is very much it is a physical process, physical sieving.
Yeah.
And if you have a filter which is very robust, you just have to clean it and you have to operate it. Of course, it operates in cross flow and dead end both, depending on the TSS. That is a more technical details, depending on the customer requirement. Yes.
Okay, let's talk about your current supply. How do you work with the businesses? Do you basically work with the engineering companies or environmental companies as they use your membranes as part of their systems? You know, whether it is upgrading the existing water treatment plant or in the new water treatment plant. Is it right? So how do you don't build your own water treatment plant? You basically supply the
No.
ceramic membranes. Yeah. Okay.
So
with modules.
from the beginning itself, we are very clear in our head. What is our forte? We asked ourselves, what is our forte? We are basically a material scientist.
Yeah.
So we know how to, build the material. So we told ourselves that we will be keeping ourselves on our forte. So we see ourselves as a membrane manufacturer and supplier. So we partnered with a lot of OEMs, ETP plant manufacturers across India. There we supply the technology, and we encourage them to build their technology, that is the complete solution, on our platform, that is Keraship ceramic. So that's how we operate. We directly do not go to the end user. We build partnership with our OEMs, and then we deliver.
Yeah, so you help them to develop the process with the ceramic membranes for the OEMs, and they execute the plant. You know? So I think that is most of the.
I would not say. Sorry to interrupt. I would not say that we developed for them. We jointly developed, because there are a lot of. They are also bringing to the table years of experience of applications. So as I told, we are a material scientist. We are not the applicator. So we need information from them. So when they build the whole solution, that is their proprietary. The complete solution is their proprietary. The membrane is, we provide the membrane. Of course, we give some basic.
Basically, you are integrating your solution, part of their solution, to the customers.
That's simple. That's correct.
So, okay, can you talk about quality and warranty of Keraship? What kind of certifications, or it's important that see, everybody knows ceramic membranes. They are user friendly, cost effective compared to the polymeric membranes. Got it? I think everybody understand this, and the applications are huge. It's also that it's important that the quality and warranty life on so what is your structure of the quality of the Keraship membranes?
So we give warranty of case to case basis. Of course, we make sure the customer understand what is the technology. That will help us to customer also will help. I mean, they will also understand what to ask and what not to ask. When you understand that the technology is ceramic, so we do take warranty. We do take warranty, normal warranty, and we give 10-year also, up to 10-year also warranty, depending on the mode of engagement with the end user and our OEM and us against the manufacturing defects. And of course, apart from that, there is nothing when you adhere to the pH and temperature. There is no problem with the membrane. We give guarantee. We take whole responsibility of the membrane. Certainly, yes.
Okay. Can you talk about quality wise? You have any certifications? Any certified at this moment? What is it like now?
So we are in process of certification. We are currently working with a lot of different government and public and private entity certifying agency, India and globally also. As you know, it takes a lot of time and also it's very cumbersome. So we are doing it with not only directly with ourselves, we are doing along with the OEMs, our OEMs.
So basically, even you don't have the certification process in process, okay, under process, or and but the quality and the warranty that you're giving, like any other international membrane suppliers, yeah, that's yeah. So that's nice. Can you, okay, finally, I want to check with you. What is the vision for the Keraship? Are you going to make a bigger size modules, or what are the what's in your on your plate now? What's next for the your
So,
company? Yeah, yeah.
so configuration wise, we are currently in the market with three different configuration: tubular, multi-channel tubular, that is the common one. Then we have hollow fiber, ceramic hollow fiber, and then we have recently introduced this flat sheet ceramic membrane that is primarily for high TSS like MBR processes. So these are all configuration wise we're currently doing, and of course we have some couple of idea for the future also. These are all for liquid separations, membrane for liquid separation. We have gas separation also, membrane for gas separation, that is the hollow fiber one. Different gas separation membranes also we are going, uh, including uh, automobile emission diesel particulate filters, DPF also. We're working with different organization, including in India and across the globe also. We have partners with uh, two IITs in India. Of course, my university is also there. We have partners with various multinational companies also. We have another partner in Canada. So we are trying to develop uh, different, membrane, because it is a membrane. It is basically a filter. You can filter any kind of fluid. So it can be gas, it can be liquid, like that.
Yeah. Good. So you continuously developing your products with working with the various research institutes and also collaborating with international organization. That's very nice to know. That is very important, so that you can keep adding value to the clients as well, and also more diversification into the other applications. We were talking about gas separation. Yeah. So okay, and Sandeep, I really thank you for joining this, the Environment Technology NewsHour, for the talking about ceramic membranes, your research work, and now I'm very proud and happy to see that as a researcher turned into entrepreneur and doing very well, and your story is a motivation for many others who are still worrying about uh, have done very good research, not commercialized. Okay, whatever it is, not talk about just only ceramic membranes, any other subjects as well. Okay, so any final message to the audience? Okay, for this presentation.
Yeah. So thank you again for inviting me and giving us this platform. We look forward to for future engagement also when we come with develop new technologies and new partnerships. So our mission, as I told, our mission was to develop a technology, economical, cost-effective technology for the masses and in the water and wastewater field. So we welcome our viewers. Any informations, any observations, please contact us. We are happy to address those concerns. and trying to come out with a solution together. Thank you. Thank you very much.
Thank you, Sandeep, once again for being part of this Environment Technology NewsHour. It's very good to know about your company and also your work on the ceramic membranes. Thank you once again. Guys, that's the end of the today's episode on the ceramic membranes from India and what is the technology and application. Please remember Keraship and do you remember Dr. Sandeep Sarkar. We learned about his work and his development of the ceramic membranes on this Keraship ceramic membranes. I hope you find this presentation and the discussion useful to you. And if you like to watch it again, you can always check on our on YouTube at Technology channel. See you in the next episode. Thank you all for joining this today's session of the ceramic membranes. See you in the next time.
Thank you.